Okay, it is 9:38 and there aren't many problems on the help board. I'm assuming since we don't have class on Thursday that everyone decided to put their homework off, which, oh boy. Anyway, I'm going to do the study sheet because you're going to have to take this test and you're probably going to have questions on the study sheet. So let me just do them all and then they'll be there. And if you want to put questions about the other lessons on, I'll answer those next week. So this is going to be in two parts. I'm going to do the first 10. They're going to be raw and real. I'm just going to do them straight. I'll have to do the calculations and everything, so be patient with me. And we're going to work through the first 10 in this video, and then we'll do 11 through 20 in the second video. These are really similar to the ones on the test, so if you can understand all these, you'll probably do really well on the test. So let's get started. The first one that we have to do is lesson 57. It's study lesson 57, means if you don't get this problem, go and study this lesson. This study sheet's a little different than the other ones that I've done. We are going to do lesson 68, number 2. So I'm just going to go over to another page to work these problems. So lesson 68, number 2. So this one says the temperature of a quantity of an ideal gas was held constant at 14,000 Ks. If the pressure of 1200 newtons per square meter was increased to 1600 newtons per square meter, what was the final volume if the volume was initially 2000 milliliters? Okay, so starting this one, it says the temperature of an ideal gas was held constant. So if something's held constant, like the one on the test, it's going to say that the volume was held constant. So let's first of all write the formula. V1 P1 over T1 equals V2, whoops, let me get this formula right, V2 P2 over T2. Okay, so we're going to substitute in. Now it says that the temperature was held constant, which means we don't need to even write the temperature in because it's going to cancel each other out. So if it's held constant, you don't even need to put it in. Whatever's constant, you can just cross out. So we have, what is it? I'm probably not going to do this whole thing. The pressure is this one. It's usually P1 V1 over T1, isn't it? But it doesn't matter the order, just so you get the temperature on the bottom. So the pressure was 1200 newtons per square meter. And the initial volume was 200 milliliters. We don't need the bottom number, right? Let's see, the pressure was increased to 1600, so it's going to be 1600. And it's going to be, we don't know what the volume 2 was. Told you this is going to be kind of more real time. So we're going to get 1200 times 200, and we're going to divide that by 1600, and we're going to get 150. Make sure that you always put your units. You get a point off right away if you don't have the units. So the question is, what was the final volume? Volume's in milliliters, so we're going to put milliliters. So that's problem number 2, one problem down. All right, the next problem is from lesson 74. We are doing practice problem 1, the only practice problem actually. Okay, so this is a problem where you have two different distances. Okay, Chad, be paying attention here. So this is from lesson 74, it's practice problem. So it's the practice problem. So Bernard raced twice as fast as the local dominista. I don't know how to say that word. Dominesque. For this reason, he raced 120 miles in 3 hours less than it took the Dominesque to race 105 miles. How fast did each of them race, and what was the time of each racer? Okay, make sure you answer each question. Don't just answer one question or you'll get points off for that. So we had two different distances. Bernard raced 120 miles. So this is the distance of Bernard. So on the test, you're going to do it like this. Only you're going to have different numbers and different people and so forth. Okay, and this is the distance of that Dominesque person. All right, and he raced 105 miles. So we have different distances, so we're going to have two different distance setups. So just remember, distance equals rate times time. So we would do the rate of the Bernard, time of Bernard is 120, and the rate of the Dominesque and the time of the Dominesque is 105. Now, we have four different variables, so we're going to need that many equations. So let's get some other equations. So he raced Bernard. The rate of Bernard was twice the rate of the Dominesque, or whatever it is. And then the time of Bernard, he was 3 hours less. So it's the time of the Dominesque minus 3 hours less. Now we have our four equations. Both of these, I got them in terms of the b variable, because then I can put them both into this equation right here. The one on the test is really similar. I did a good job at finding one that's really similar. So we're going to fill them all in. We're going to put this in for the RB and this in for the TB. And so RB is 2R sub D. TB is TD minus 3, and that equals 120. So we'll distribute that through. So we get 2RD TD minus 6RD equals 120. Okay, this is the miracle problem. We have RDTD, and here's RDTD, so we can substitute it in. So 2 times 105 minus 6. Now we only have one variable and one equation, so it's totally solvable. So we're going to get negative 6 R sub D. So this is going to be 210, right? So I'm going to subtract 210 from 120 minus 210. And so we're going to get negative 90 divided by negative 6. And we're going to get RD is 15. Let's answer the questions here. So it says how fast. So the rate of the Dominesque was 15 miles per hour. All right, then we're going to go back up. We're going to find the rate of Bernard. He's twice as many. So the rate of Bernard equals 30 miles per hour. And then it says what was the time of each racer. So the time, we would just do, we would just substitute those in. Let's see here, here's a time one. But we have the rate of the Dominesque was 15. TD equals 105. We'll take 105 divided by 15, and we get 7. So the time of the Dominesque was 7, and the time of Bernard is going to be 7 minus 3, which is 4. Just a tip, on the test, it's going to ask them how long they traveled, which is time. So, okay, so it's not that much different. Okay, 2 done. Let's move on. We're going to lesson 67, number 4. 67-4. So that one is, there were 75 more nurses than doctors. In fact, 8 times the number of nurses exceeded 10 times the number of doctors by 140. How many of each were there? Yikes. Okay, so 75 more nurses than doctors. So I'm going to do the number of nurses equals the number of doctors plus 75, right? There's 75 more nurses, so I had to add 75 to the doctors. In fact, 8 times the number of nurses, exceeded 10 times the number of doctors, 10 times the number of doctors by 140. Ooh, so that one's a read along. It's a little tricky. Let me see what the one on the test looked like. Yeah, really similar, only it's marbles. So 8 times the number of nurses exceeded 10 times the number of doctors by 140. It's worded really weirdly. Okay, so what I'm going to do is I'm just going to do substitution. So I'm going to take this and I'm going to put it in here. So 8 times the number of doctors plus 75 equals 10 times the number of doctors plus 140. I'm doing this problem to make sure I did it right. So distribute through 8 times the number of doctors plus 8 times 75 is 600 equals 10 number of doctors plus 140. Let's get all the doctors on one side. So -2 number of doctors equals 140. If I got a negative number, oh, I knew I did something wrong. I would know I did something wrong. So we get -460. We're going to divide that by -2 to make it positive. So the number of doctors is 230. The question will say how many, what does it say? It says how many doctors, how many were there of each? So you need to answer both questions. So we just have to add 75 to that, and we're going to get the number of nurses. So the number of nurses, so we just add 75 to that, and we get 150, noops, I subtracted 230 plus 150, and we get, wait, did I add the wrong number to it? Hold on, let's see, 75. 230 plus 75 is 305. So the number of nurses is 305. Alrighty, number 4, lesson 71, practice A. Just a few pages over. 71A. Okay, so we have to derive the quadratic formula. That is actually on the test, guys, so you just need to look at what I do and kind of memorize it and try to understand it would even be better. So we're going to derive the quadratic formula. So this is number 4. It's lesson 71, practice A. All right, so we're going to derive it. We're starting with ax squared plus bx plus c equals 0. Okay, kind of your nightmare problem. You guys ask this all the time, and I've done it every week. So hopefully you'll get it. We're going to derive the quadratic formula, which we're going to solve for x so that we have a formula that we can just put a, b, and c in and get x. So in order to do this, we need to complete the square. Now, back in the day, you did completing the square problems, like you had 2x squared plus 3x plus 4 equals 0. Remember these? And you would divide everything by 2 because you can't have a coefficient, right? So we're going to get x squared. If we're doing this problem, okay, I'm just doing this just for showing you what we're doing. And remember, we would like kick the 2 over here, and then we would divide this one by 2 and square it to get the replacement guy. Okay, we're going to do the same thing, only with variables instead of numbers. So let me just erase some of this. All right, I don't have a good eraser, so I just have to backspace a lot. Okay, so in order to complete the square, you can't have a coefficient of x squared term, so we're going to divide everybody by a. You get an a, you get an a, and you get an a, and don't forget the 0. Okay, so you're going to get x squared plus b over a x. Now this isn't a perfect square, so I'm going to get a replacement guy, and I'm going to put him over, this is going to be 0, right? So I'm going to put him over here, and we have to add the replacement guy to both sides. How do you get the replacement guy? Well, you divide the term in front of the x, the coefficient of the x, by 2, divide it by 2, which is the same as multiplying by a half, and then we're going to square it, and that's what we put in both sides. So we get b squared, and then this would be 2a squared, which would be 4a squared. You can see it starting to come together, right? 4a squared. All right, now we have a perfect square trinomial on the left. That's why we got the replacement guy. So it's going to factor into x plus b over 2a, quantity squared. And then on this side, the common d is 4a squared. So this one needs a 4a, right? So it's going to be -4ac plus b squared. All right, now, if you remember how we completed the square before, we did that. And then we took the plus or minus square root of the answer side. And that, when you square a square, it comes out. So you get x plus b over 2a. And that's going to equal, look at this, how it's coming together. Plus or minus, I'm just going to rearrange, b squared minus 4ac. You know where you're going if you have the formula memorized, which you better, over 2a, because the square root of 4 is 2. The square root of a squared is a. So all we have to do now, the final step, is we're going to move this guy over there. So we get x equals, so it's going to be -b. The denominator is the same, so we can put it all over 2a. Sometimes there's a delay to my pen because I'm on the internet doing this. Plus or minus b squared minus 4ac. And this is the quadratic formula, and we derived that. Why don't you show one of your parents how you can derive the quadratic formula for practice? They would be very impressed, I'm pretty sure. Okay, finally, number 5. We are on lesson 71, practice B. So we're going to use the quadratic formula to solve. So we're going to take this formula and we're going to actually use it to solve an equation. Now, the benefit of this is if you cannot factor something, it's easier to factor, but we're going to use the quadratic formula. So this is number 5, and it's from lesson 71, it's practice B. So practice B. Practice B. All right, so we have the equation 2x squared minus 6x plus 4. My guess on the test is it's not going to be as easy as this one. I could have picked a more difficult one, I guess. You have to set it equal to 0. The one on the test is going to not be set equal to 0. It's going to look more like this. 3x squared plus 2 equals negative 5x. It's going to look like this, and you have to put it in this form in order to use the quadratic. Anytime you have a quadratic equation, which means you have a degree of 2, you need to set it equal to 0. So do that. Now, on this one, do you see how everything's divisible by 2? If you can see that, you can kind of reduce the equation. Everybody has to be divisible by the number that you use, though. So I'm going to divide everything by 2 before I use the quadratic formula. So I'm going to get x squared. This is a good tip for the SAT because it makes your work less. Okay, now we get A equals 1, B equals negative 3, and C equals 2. All right, so my computer's going to do something weird in a minute, maybe. Okay, I think it was okay. All right, so you're going to take the coefficients. So you have a 1 in front of here, a negative 3 is in front of your x, and the c, remember it's ax squared plus bx plus c equals 0. So you're just going to plug those into the quadratic formula. I think you know how to do this. So you get x equals negative b, so it's going to be positive 3, plus or minus b squared, which would be 9, minus 4 times 1 times 2, all over 2a, so it's going to be 2 times 1. All right, and then we simplify underneath the radical, so you get x equals 3 plus or minus. So this is going to be 9 minus 8, which is 1. It's not going to be this easy on the test. So you're going to get 3 plus or minus 1 over 2. So you're going to get 2 answers. This would have been factorable. If you don't get a radical, you could have factored it. But you have to do the method that they say. So 3 plus 1 is 4. 4 divided by 2 is 2. 3 minus 1 is 2. 2 divided by 2 is 1. And there you go. That's your final answer for that one. All right, number 6. Lesson 56, all the practice problems. Don't you love that? Okay, 56. These are the circle problems. So, lesson 56, this is number 6. Lesson 56, all the practice problems. I'm not going to do all of these, but we're going to just talk about basically the ones that I find are on the test. So let's do practice problem. Let me just see which one looks most test-like. None of them are as hard as the one on the test. Let's just do C. So C looks like this. The secants intersect outside of the circle. So we have out here, and then we have here. And so we have 70 degrees and 20 degrees, and this is x degrees. So if it intersects outside of the circle, you subtract them. Now, on the test, it's not going to give you, it's going to give you one down here. It's going to give you this one, and you have to find this one by subtracting it from 360. So for this particular one, you're going to do 70 minus 20 divided by 2, which is going to be 50 divided by 2, which will be 25. So you'd say x equals 25 degrees. There's 2 of them on the test. Let's see, what's another one? I'm just going to help you out a lot here, actually, because if you're watching this video, points for you. Okay, so So there's going to be one like this. So it's not really one that's on these practice problems, but I'm going to make one up for you because I want you to do well, and I want you to watch my videos, and you'll know if you watch the videos, you're going to get extra bonus help, right? So the one on the test is going to look more like this. You're going to have something like, let's see if I got this right. You have something like maybe 100. I'm going to keep my numbers easy for myself. 100, and let's do this one, 150, and this is x. Okay, so we don't know what this arc is right here, right? You don't know this one. So what you're going to do is you're going to take 360 and you're going to subtract, add these together, 250, and you're going to subtract those and you get 110. So this is 110, and then you're going to subtract these two and divide by 2. Okay, so that's one's more like one on the test, and then there's one like this. Okay, that's a circle. Again, there's 2 of these. It's going to look like, oops, got a little delay. Okay, so it's going to look more like this. Ooh, what do we do with that one? Okay. So it's going to intersect right like that, and you're going to have to find x degrees right here. And they're going to give you that this is 150, or whatever they give you. So this is an inscribed angle, right? So we know that the inscribed angle, it's half of this. So this is going to be 75. These are vertical angles, so x is going to equal 75 degrees. If you watch this, you should get this right on the test. So hopefully you watch these. Okay, we are moving on. Lesson 70. Let's see which one this is. So we're on number 7. Lesson 70, practice problems. Oh boy. So let's see what we got for that one. 70. Ooh, I love these. This one is, there's only one practice problem. So this is the practice problem. It's mx equals p. This is the free the variable. Z over x plus k plus 2s over y. So we are to find k. So solve for the right variable. On the test, we are going to be finding c. It's a little bit different. Of course, I can't give you the exact problem, right? Okay, so whenever you're doing these problems, you want to first distribute, get rid of the parentheses. So pz over x plus k plus 2sp over y. Then we want to get rid of fractions by multiplying everything by the common denominator. The common denominator, LCD, is y times x plus k. So we're going to multiply everything times that. So make sure you do everything. Y, x plus k, this looks like a pretty hard one, times y, x plus k, times y, x plus k. So everything gets the common denominator. Yikes. Okay. On this side, we're just going to get, if we distribute it through, we're going to get mx squared y plus mxyk. Yuck. Okay, so I had to take mxy times this and mxy times that. mxyk. Okay. Then over here, these cross out, fortunately, so you get pzy plus the y's cross out, and that's an s. So we're going to get a 2spx plus a 2sp, I'm going to run out of room, k. Okay, now we are solving it for k, so we're going to get all the k's together. All the k's on one side. I'm going to move them to the right side for, I don't know why. So we get mx squared y minus pzy minus 2spx equals 2spk minus mxyk. And then we're going to factor out the k over here, and we're going to get 2sp minus mxy. And then we have all this stuff, mx squared y minus pzy minus 2spx. And divide both sides by 2sp minus mxy, so they cross out, right? And our final answer is 2sp minus mxy equals k. And that's your answer. So the steps for these would be to get rid of your parentheses by distributing, multiply everything by the common denominator, get all the variable that you're looking for on one side, factor out the variable you're looking for, and then divide by what's left after you factor it out. Okay, number 8, lesson 27. So we're going back in time here. Lesson 27, and we are doing practice B. How about that? So we're going back. Practice B. Okay. So we have, this is number 8, almost done with this video. It's lesson 27, practice B. So we have z plus 3 over z squared plus 5z plus 4, that's a 5, minus 1 over z times z plus 4. Okay, this kind of problem, I'm looking at the one on the test, you're going to have to factor before you start. So this denominator is already factored, this one needs to be factored. So it's a simple factoring, and the one on the test is a simple factoring as well. So it's going to be z plus 4, z plus 1, minus 1 over z times z plus 4. Okay, no equal sign, so you can't get rid of the denominators. It's like adding 1/2 plus 1/3. You need to find a common denominator, no equal sign, so you can't multiply everything by the denominator and get rid of the denominators. So we get z plus 4 times z plus 1 is our common denominator. This one doesn't need anything, so it's going to be z plus, well, the one on the test is harder, guys, z plus 3 minus, now this we're going to have to take this one, oh, I forgot the z. Hold on. The denominator, don't forget the z here. Okay, so we have to take this one times a z, and this one needs a z plus 1. Now, be careful with this negative sign. Also, you might have to FOIL on the test. If it's a binomial times a binomial, you're going to need to FOIL. Minus z minus 1. See how I took that through? Make sure you do that. And so our final answer is z squared plus 2z minus 1 over z. These z's are killing me. Look how ugly they are. Z plus 4. Otherwise, they're going to look like 2. Z plus 1. Okay, on the test, you might have to take this one times like a z plus 1, and then you have to FOIL it. So don't forget to do that. That's my hint. Okay, so that was number 8. Let's go into number 9. 9 is lesson 73, practice B. Practice B. Back to where we are. 73, practice B. Okay, a big, ugly, radical problem. Good news, the one on the test isn't as hard. So let's try this one. So we have 2 root 12 minus 3 root 3 all over 2 root 3 minus 3 root 2. We're multiplying the top and the bottom by the conjugate. And what that does is it's going to eliminate the radicals in the denominator, which are illegal. Okay, so we need to FOIL the top. So first is going to be 4 root 36. The outer is going to be plus 6 root 24. The inner is going to be negative 6. Root 3 times root 3 is just 3. Minus 9 root 6. The bottom, the outer and the inner cancel each other out. That's the whole point of this. So we just do the first and the last. So it's going to be 2 times 2 is 4. Square root of 3 times square root of 3 is just 3. 3 times 3 is 9. Square root of 2 times square root of 2 is just 2. See how there's no more radical in the denominator? That was the whole point of multiplying by a conjugate. Okay, now we just have to clean up all the mess we made. So this is going to be a 6, right? And this is going to be the square root of 4 times 6. So the 2 is going to come out. So let's write that down. So we're going to have 4 times 6, because the square root of 36 is 6, so that's 24. Plus The square root of 4 is 2, so 2 times 6 is 12, and we still have the square root of 6 underneath there. Minus 18 minus 9 square root of 6, all over 12 minus 18, which is negative 6. And simplify it even further. Simplifying is a big deal in these problems. So 24 minus 18 is 6 plus 3 root 6 all over negative 6. Okay, you can see we can take a negative 3 into all of these. So it's going to be negative 2 minus root 6 over 2. I chose to take the negative because I don't like having a negative in my denominator. It's not wrong, but it's not best form. So I took 2, divided 2 into this, negative 2 into this, and negative 2 into that, and there is your answer. Okay, last one of this video is number 10. So here we go. Okay, number 10, and it is lesson 73. Number 23. If you want to study it, you can see I have study lesson 47. Okay, so lesson 73:23. Don't have to turn too far. Yay. Okay. Oh, one of these. Someone always puts these on. I remember doing this exact problem. So, all right. So let me look on the test, see what kind we got. Ooh. Okay, it's almost exactly this problem. Oh my goodness, I can't believe I gave you one so similar. Okay. So you have to make all the bases the same. We're going to get rid of the radicals and make them fractional exponents. So the 2 is on the seat because it's square root. Seat goes on the bottom. We have the 3 to the 1/2. Now you have to make all the bases the same or you can't add your exponents. But I can make 9 have a base of 3 by making it 3 squared. So now I'm going to work inside my parentheses, add the exponents. 2 times 2 is 4 plus 1 is 5/2. So 3 and 5/2 to the 1/2 power. Now we have a power to the power, so we multiply. 3 times 3 to the 5/4. Now bases are the same, so we add our exponents. The exponent on here is a 1, which is the same as 4 over 4. So it's 3 to the 9/4, and we are done. Okay, so that was the first 10. I'm thinking will take longer than the next 10, so we'll see. So there we go. The study guide for test number 19.